Okay, so there's multiple goals of this course. The first goal, and I'll kind of put these in the priority I see them. Okay, the first one is that you can select the appropriate abstract data type and then data structure for an application. And this is really, in some sense, the inspiration why we wrote this book and what really is going to be different about the book and what I really think is valuable. Right? There's a lot of courses and there's a lot of books where you can learn a bunch of data structures. And in isolation, people can tell me what this data structure does, how the methods work. They can tell me how fast things run. But if in later coursework and more importantly in the careers that follow, you don't ever use them because you don't really know what they were for. You just sort of know them in isolation and you really haven't thought about what is this good for versus how do I go through the mechanics of drawing out the data structure and the mutations that occur, then it really won't buy you much, right? If you're going to come out of this course, the first thing I'd like you to do is at least know when you're out later and you need to implement something and you need something more than a linked list or a queue or stack or array or some sort of very basic data structure, you'll know how to figure out what data structure you need. You can always reread the details of that data structure if you forgot those. But if all you know is the individual data structures and don't know how to figure out which one to go to, then you'll end up not using any of them. Okay, and this is something that my course has emphasized through homeworks. It's just now we have a little more mechanism to focus on that in the course. So I'm really going to put that as the highest priority because that's what will allow you to use this material later. The next thing is you should be able to use variations of standard data structures and algorithms. And understand how the changes affect both the correctness and the time complexity. Right, so it's great to have an application and you can just, right out of the box, you can take the CD here, you can take the code and just as is, it fits perfectly. But that's not always the case. It's often the case that you need to do certain kinds of optimizations or additional functionality. And so you want to understand how these data structures work so that you can make appropriate modifications. And can you understand, will this change still lead to it behaving correctly? Will it still be efficient? And so, once you know how to select the data structure, it's great to look it up, but you have to be able to modify it, and there's a certain amount of understanding. So sure, I do want you to understand the data structures we're going to cover. And the reason you want to understand it is primarily so you can make modifications as appropriate. The other thing I'm going to do, let's get rid of this, is I want to give you a little bit of an introduction into algorithm design. And this is one thing that is not in our book, and I'll be providing handouts for that. Because although this is very much set on standard data structures and algorithms and understanding how to modify them and when to use them, it's not about designing new algorithms. And while that's not the focus of this course, and it never has been, I know for some of you this is the only data structures and algorithms course you're going to take. And I feel I'd like you at least to have some exposure to techniques that can let you design brand new algorithms. Not modify existing ones, but design a new algorithm for a problem. And so I think it's important to get a little bit of exposure to that. For those who really like that, this is really the main topic of 441. So for those who really want to look at algorithm design, that's really where you'll want to go from here. But you'll get a little bit of a taste here. And again, I'll provide handouts for that And the Corman, Lyserson, Rivest, and Stein book does really do some of that. Okay. The next thing is to quickly determine how efficient an algorithm or data structure will be. And we'll talk about that today. That's where we'll actually begin. And so as we design data structures and algorithms, or modify data structures and algorithms, how can you figure out if it'll still be efficient? Right? We'll talk more. I mean, I can obviously do the standard. Why don't I code it and test it and run it? And we'll see later today that there's problems with that. And so we want to figure out the way I can do a very, very quick analysis to kind of say, okay, this one's not going to even be worth implementing. And then move on and try to sort of filter through and even have a way of talking about it. And so we'll spend a little time doing that now, but that's something then we'll be using throughout the course. And next, finally, I would like you to be able to implement what you learn and apply to a variety of applications. And that'll be through the labs. So you'll have some labs where you're just implementing things that you've learned. But sort of the interesting thing is every data structure in here and algorithm is fully implemented in Java for you. Right? So I can't ask you to do that. And in some sense, that's good. Instead, what we'll be asking is, you've got this. Can you use it now for this application? And can you understand how you might need to modify it and make those modifications? So there'll be some of each. A few of the labs, I might introduce a new data structure that's a variation of what's there that we don't talk about and ask you to implement that. So we'll do a little bit of each. We're really going to set up the labs with the expectation that you will implement them in Java. With that said, everything I'm talking about, how you pick an ADT, how you pick a data structure, how these data structures work, how efficient they are, it doesn't matter the language. So the material you're learning in this class is relevant to C++ or all kinds of languages. It's not only relevant for Java. It's just the language that we're going to use for the labs. So I just want to make sure everyone doesn't sort of think this is only sort of data structures for Java or algorithms for Java, because that's not the case.